Good morning, Year 6. Welcome to lesson 2 of our new light unit and your final lesson at home doing science, because next week we're back into school, which is amazing. So today, hopefully you've been told that you will need a torch. If you haven't been able to get one, it's not the end of the world. You can use my data, but it's going to be a lot more interesting and engaging for you if you have access to a torch. It can be any size, small, little, medium. The light on your phone would be good, for example. And you're going to need various household items. Now, don't worry about getting these yet, but by household items, I mean things like book, paper, t-shirt, pots, cutlery, okay? But you don't need to decide on those objects until we get to the investigation. Before we start, as always, total recall, you've got 4 questions. Pause the video and have a really good go at answering them. I'll reveal the answers one by one and just spend a little bit of time reading it, pausing if you need to. So, well done if you managed to remember all of that, or even some of it, and if you didn't, hopefully it's jogged your memory. Today then, in your science book, could you write the short date and title, and then have a read of the Wilf, and then join back to talk about the learning power. Today the focus is listening. Lots of key information, knowledge and vocabulary in this lesson, so make sure you're really focused. Last week then, we learned that light travels in a straight line, and you drew some examples of light sources such as a lamp. Remember, a light source creates its own light, and it travels straight into the eye. But this week we're moving on a step and looking at reflection. Now, what is reflection? Pause the video and have a think. So light reflects when it bounces back off a surface or object. It's really important. That is what reflection is. All objects reflect some light, otherwise we couldn't see them. And we're going to watch a short video now on reflection.
We see things when light bounces off objects into our eyes. This is called reflection. Almost everything reflects light, but some surfaces are better reflectors than others. Dark or dull surfaces, like slate, concrete and wood, are poor reflectors. Most of the light that hits them is absorbed and little bounces back off. Uneven or rough surfaces, like sand, leather and stone, scatter the light that hits them. While some light is absorbed, most of it bounces off all the tiny bumps on the surface in many different directions. Smooth, light-coloured or shiny surfaces like glass, water and metal are excellent reflectors. All the light that hits them bounces back off. We say they are highly reflective. Mirrors. Mirrors are highly reflective. They are made by putting a layer of shiny silver underneath a layer of glass. Almost all light hitting a mirror bounces back off it. The smooth surface means each beam of light bounces back in just one direction. A mirror reflects light so well that when we look into one, we see our own face looking back. But you only see your face if you are directly in front of a mirror. If you look into a mirror at an angle, you will see light reflected from objects to the side of you instead. Light reflects everywhere, even behind you. This allows us to use mirrors in many places to see where we normally can't. That's very useful at the dentist's.
Okay, awesome. So, some key vocabulary in that video, which we're going to go through in a moment, and also lots of information about different types of surfaces that we are going to be investigating to see whether that is actually correct or not. So, some of the really key information in that video is now on this page. What I'd like you to do is pause the video, read the definition of shiny, matte, and luminous, and then can you have a go at these 3 questions in your book for me, please, to make sure that you've understood what each word means. So pause the video and join back in a moment. Question 1 then, what do shiny objects do to light? Well, shiny objects reflect most light that hits them. Explain what a luminous object is. A luminous object is a light source, so it creates its own light. For example, a candle. And what do matte objects look like? Well, matte objects are less smooth than those of shiny objects and duller. Awesome. What I'd like you to do now is either jot down or talk to an adult if you're working with one, the following things. 5 shiny objects, for example, a metal spoon. 5 matte objects, for example, a piece of paper. And 5 luminous objects. And if you're not quite sure, go back, read the definitions again, and that will help you. Once you've done that, join back, and we're going to watch another video on good reflectors. These examples then, the moon, the high-vis jacket and cat's eyes are all excellent reflectors. They do not emit light. They are not light sources. They do not create their own light, but they are excellent reflectors. Let's watch a quick video on that.
Winky's the name. Wee Willie. I'd been running through the streets for years. Upstairs and downstairs in my nightgown, checking everyone was safely tucked up in bed. Everyone in bed?
Yes, Willie.
It had never been a problem before, but tonight, something was different. I set off through the streets as usual. It seemed a perfectly ordinary night. As I turned the corner from Main Street into an unlit alley, the world went black. I lay there in the darkness, wondering what had gone wrong. Was it something I'd done earlier? That afternoon, I decided to do something different. I was bored of the same old nightgown and candle. That outfit was getting stale. No one noticed me anymore. I just merged into the night. I needed to make my mark, and what better than some new gear? Little did I know what disaster lay in store. I decided to compare some outfits, but nothing seemed to be right. The lamps and the torches were heavy and clumsy, the clothes drab and boring. I needed to see in the dark. And as I stood there looking, it came to me. The bright yellow jacket with reflective strips. Of course, it stood out. I looked outside. It was getting dark. There was no time to lose. I quickly threw on the jacket. I glanced at the candle. I didn't need it now. It was history. I stepped outside. I set off through the streets as usual. It seemed a perfectly ordinary night. As I turned the corner from Main Street into an unlit alley, the world went black. I lay there in the darkness, wondering what had gone wrong. Was it something I'd done earlier?
Okay, so that example there tells you that although certain objects and materials can be excellent reflectors, it doesn't mean that they make their own light. Today then, your main task is to investigate reflection by shining a torch on various objects or surfaces around the room to see how bright the circle of light looks on each of them. So this is now where you can start thinking, right, I might pick maybe 6 to 8 objects to test. So it could be a book, a mirror, the carpet, a piece of paper, a piece of clothing. All right, I'll show you what I did in a moment and you perhaps magpie some of those objects. Now, bronze, you are going to do this question. You are going to investigate whether smooth surfaces are always more reflective than rough ones. And I've done that, so you can see my example in a minute, which will support you. Silver, I've given you a choice. You can go with that question, or you could perhaps investigate if white or pale surfaces are always more reflective than black, dark ones, or if some surfaces reflect equally brightly when the torch is held at different angles to them or not. And again, here's some examples of the sorts of things you could test. T-shirt, a mobile phone screen, carpet, paper, mirrors, plastic, all of different colours and perhaps different textures. You're going to record your results using a Carroll diagram. Again, don't worry, I'm going to show you exactly what that is in a moment. To group your data according to the yes-no question you investigated and how reflective or not the object surfaces were. A Carroll diagram is used to organise data and group it according to whether it fits certain criteria. A Carroll diagram sorts data by looking at more than one criteria. Now, at the moment, if you're thinking, what is Mr. Webb going on about? It will all become very clear. So, my key question, and bronze, this is your key question. Silver, you can go back and choose one of these 3, is, are smooth surfaces always more reflective than rough ones? So, you need to label your Carroll diagram to match the question you are investigating. So you can have a quick read of that, but it's going to make more sense if you take a look at this. So, you will need to all draw a table like this. And you're going to all have reflective in this box and not very reflective in this box. And then depending on your investigation, you're going to label these boxes on what it is you're investigating. Now, I investigated smooth surfaces versus rough surfaces. You might be doing bright surfaces versus dark surfaces. So as long as you label reflective and not very reflective here, and then your actual investigation questions here, you're going to be able to sort out the objects depending on what happened. So for example, when I shined the torch at my phone screen, I could see that it was reflective and it was also a smooth surface. So it goes into this box. However, when I shined a torch on a phone case I had, it wasn't very reflective and it had a bit of a rough surface, so it was in this box. And once I tested several objects, I was able to organise my data, and then I can analyse this table to see whether smooth surfaces reflect better than rough surfaces. And as you can see, that's correct. Because look, here, all these objects that had a smooth surface were very reflective. Those that had a rough surface weren't very reflective. Now, not all smooth were good reflectors, and not all rough surfaces were bad reflectors, but the majority were. And I can look at that and I can see a pattern straight away. Smooth surfaces are more reflective than rough surfaces. And I've answered my question through that investigation. If that all seems a little bit confusing, just rewind and listen through again, okay? And if you're super stuck, Teams is there. I'd like you to have a go at that investigation now. So you need your torch, go and find 6, 7, 8 objects, draw your Carroll diagram, and investigate your question. Off you go. Okay, so I know your teachers can't wait to see the results of your investigation. If you did the same investigation as myself, did you find a similar pattern? If not, what might have happened? Before we move on to task 2, a quick pit stop. You can pause the video here at any point in the lesson if you just need to recap on some key vocabulary. Now we've completed the investigation, your second short task is just to draw some ray diagrams, because in each test, the light travelled from your torch, reflected off an object, and then travelled into your eye. So last week, where we were just looking at a light source, so the light source travelled straight to the eye, this time we know that we can see objects because light reflects off them. I'd like you to draw a ray diagram to show how you would see a toy teddy. And then I'd like you to draw one to see how you would see a reflection of a toy teddy in a mirror. Sounds a little bit challenging, but just give it a go before you look at the answer and then come back. Hopefully then yours looked a little like this. So I use the sun as a light source. It shines on the teddy, it reflects back into my eye. That's how I see the teddy. This time, my light source is a torch. It hits the teddy, bounces onto a mirror, and then reflects into my eye. Well done if you managed that. Now, before we move on to the quick summary in the plenary, I'm just going to show you some extra learning you can do if you wish. I know some of you really get into your science, so I'm not going to read through it. You can pause the video, and these are just some tasks that perhaps you'd like to do. So here's the first lot of tasks you could possibly do at home. And here's the second. And to finish, we're just going to recap our key learning. So we know the idea that light travels in a straight line can explain how non-luminous objects are seen. So for example, a table doesn't create its own light. So how do we see it? Light bounces off the table and reflects into our eye. All surfaces reflect some light, some better than others. We know that from our investigation. And shiny surfaces reflect light better than matte surfaces. Well done for today's science, and I can't wait to see you next week for Science in School.